Hello everyone, myself Hans. Today we are going to solve the given problem from triple integral. Question is given, evaluate the triple integral. Let's solve the problem. Given integral is given triple integral is I is equal to integral limit is 0 to 4 and 0 to 2 root z, and here 0 to under root of 4z minus of x square dz dx dy. Given triple integral, first we have to integrating with respect to y, then we have to integrating with respect to x, and the last integrating with respect to z. First, here the limit of y is 4z minus of under root 4z minus of x square, and the limit of x is 2 root z, and the limit of z in variable 0 to 4. Let's solve, and further we have to integrating with respect to y. We get here integral I is equal to 0 to 4 and 0 to 2 root z, and integration of dy we get y, and put the limit of 0 to under root of 4z minus of x square, and putting the upper limit we get here integral of 0 to 4 and 0 to 2 root z, and in place of y we have to putting upper limit we get here under root of 4z minus of x square. Here once again we have to integrating with respect to y, then remaining is here dz into dx, and here we have to putting the lower limit here we get here dz into dx, and from here we have to integrating with respect to x. Using form, we can also write the given integral in the form of 0 to 4 and 0 to 2 root z, and in the under root we can also write here 4z is written as 2z to the whole square 2z ka whole square minus of x square, and here is dx and dz is taken outside. We have to integrating with respect to x, and using the formula we have to using under root of a square minus of x square dx is equal to xy2 under root of a square minus of x square plus of a square by 2 sine inverse of xy. Using the following formula to integrate the with respect to x here, so we are writing here integral I is equal to integration 0 to 4, and here we have to integrating, let here a is 2z, so we have to writing here in place of x by 2 under root of a square, here is on is a square, we get here 4z minus of x square plus of a square by 2, we get here 4z by 2, and sine inverse of in place of x by 2 here, so we have to writing here x, and a is 2z, and applying the limit here 0 to 2 root z, and we have to applying the upper limit, so we have to writing here integral of 0 to 4, and we have to putting in place of x 2 root z, here we have to put in place of x 2 root z by 2 root z by 2 under root of 4z, in place of x we have to put in here 2 root z, so we have to get in 4z, on squaring 2 root z we get here 4z, and plus of 4z, here we have to cancel out the term, 2 2s are 4, we get here 2z, 2z, and here in place of sine inverse of in place of x we have to put in 2 root z. We get here 2 root z upon 2 root z, and remaining is dz. And further from here 4z minus 4z we get here 0, then these parts becomes 0, and from here 2 root z to 2 root z is cancelled out. Then we have to further solving here. This is integral I is equal to integral limit is 0 to 4, and we get here 2z plus of 2z, and here sine inverse of 1, 2z sine inverse of 1, and we know that the value of sine 1 is sine pi by 2, sine pi by 2 is 1. So we have to write in here once again. We have to write in here integral I is equal to integral limit is 0 to 4, and here is 2z is taken outside, and place of sine inverse of sine the value of sine 1 is sine pi by 2, and dz, and from here we get integral I is equal to integral limit is 0 to 4, 2z into sine inverse to sine is removed, we get here pi by 2 into dz. 2 to 2 is cancel out. Then we have to remaining is integral limit is 0 to 4, and here is pi is taking outside here, pi into z into dz, and we have to integrating with respect to z here. Integrating with respect to z, I is equal to pi on integration of z dz is z square by 2, and putting the limit 0 to 4 and applying the upper limit here, we get integral I is equal to pi into, in place of z we have to put in 4, we get here 16 upon 2, and cancel out the term, 2 8 is 16, we get here integral I is equal to 8 pi. This is the required solution of the given triple integral. Thank you class, and thank you for watching.